This clip is about the Network Explorer part of the PARMS software. The Network Explorer is used for strong visualization and also to drive different parts of the modeling via the planning scenarios and the priority clusters. So in terms of the Network Explorer, you can see here that I have a range of folders that are available to me. If I explode those folders, you can see that I have queries that sit underneath each folder. I can set up a query simply by pressing this button here, or by right-clicking anywhere in the panel and pressing New Query. If I want to rename the query, I simply right-click into the query name, press Rename, and then rename it as I wish. If I want to delete, I simply right-click again, press Delete, and that removes it from the Explorer tree. So let's dig into the Network Explorer a little bit more. We have our toolbar at the top, New Query, Save Query, refresh the queries, and save all the open queries. We have our Explorer tree, which we build up in terms of folders and queries. If those queries are blue, then they are shared, so others using the software in the business will be able to see those and use those queries. If they are white, like the selection one here, that is simply my own personal query. So if I want to share the selection query, what I will need to do is create a new folder and then rename that. So perhaps I want to call it Poor Material. And then I can shift my selection into that simply by dragging and drop it. And then I can share the folder. Now, everybody who uses the software can use my query that I have just set up called the selection. Again, if I want to unshare it, I simply do the opposite. Okay, so let's add a new query into Poor Material and set that up using the query controllers. If I want to set up a query, I simply right-click on the folder and press New Query, or I can use the New Query button in the toolbar. So when I open up a new query, I will rename it. And this time, I'm going to focus on AC pipe that is poorly performing, say, over the last 2 years. So I will rename the query so that it reflects the purpose of the query. So AC failing over the last 2 years. Now, how do I set up that query? Down here, we have the query controller. We have a simple query controller and an advanced query controller. You can set which one you see by going into the user preferences and selecting whether you wish to see usually the advanced or the simple. The simple one contains most of the parameters and variables you'll wish to interrogate most of the time. The advanced query controller is a little bit more busy, but it contains some other things to control which assets, which failures you pull up. In this case, we're doing a reasonably simple query. So we'll go back to the simple query controller. So we will select AC as the material. And then the other criteria we're interested in is failing in the last 2 years. And we'll define that as saying at least one failure over the period 2 years. If I now save that query and then close it down, every time I open up that query, it is set as I wish to identify AC pipes that have failed in the last 2 years. As you can see, there are a range of options around setting up the query, so we can restrict it to different diameter criteria. We can select specific assets, shut-off blocks, pipelines, and a range of spatial data to do with soil types, area classification, locations, etc. So a lot of flexibility even through the simple query controller and even more through the advanced query controller. If we run that query, it will bring all of the assets back that meet the criteria that we've specified. The more constraints we set, the less assets we'll get back. So for example, if I look at how many assets have failed 3 times in the last 2 years, I will get only one asset back. You can see here that the asset has failed 7 times. If I want to reset the query back to what it's saved to, I simply press the reset query button. I can then run that again, and it will again bring up all of the AC pipes that have failed at least once in the last 2 years. Let's have a quick consideration of what data is presented to us through a query. Here you can see we have the assets data. We can pull down this pull-down menu and jump to different views. We can use the buttons to move across the views sequentially, and we've got some shortcuts to jump to commonly used views. So we have the assets that meet the criteria that we've specified in the query controls. We can look at the failures associated with those assets. We can look at the display, which shows us where the assets are in the network. And we can look at a summary, so we can see that there are 26 assets that meet the criteria that we've specified. We can look at aggregated data. So this is now the selections that we have made, aggregated in different ways, as listed here. Pipe prioritization factors are factors of interest which we use in prioritization. So let's set up a query for assets that are near a rail line. Again, we'll right-click on our folder where we want the query to go, start a new query, we'll rename that, and then we're really interested in all assets that have the pipe prioritization factor assigned to them near a train line. So in this simple view, the pipe prioritization factors are accessed down here. So we press the plus button, and that will show us all of the pipe prioritization factors that are built into PARMS. So in this case, we're interested in selecting assets that are near or proximate to a train line, and click OK. I will save that, and then if I run that, it will come back with just a handful of assets. Again, remember, this is a demo database. I can again go to the GIS and view where those are. I can look at the summary. So from a risk perspective, I'm interested in assets that are failing that are close to a train line. If I return to my data, if I look in my lifetime failures, I can see that this asset here is the only asset out of the 5 with any failures. So this asset is a DI pipe, DN225, and it has 3 lifetime failures on it. I can select that asset out of the list simply by clicking on it, as you can see here, or I can extend my selection by dragging down. I can clear the selection by clicking on this button here. If I've got an asset particularly selected, if I then go over to the failures, I will only see the failures associated with the selection. Similarly, if I go to the summary, it's now only the summary associated with that selection. If I go back to my asset table by pressing the icon here and then clearing the selection, if I then go back to the summary, you can see again, I have 5 assets, not just the 1. For the purposes of the demonstration, let us set up a new query, and let's call this one old cast iron. If I want to select all cast iron, I open up my material, I select the material cast iron and apply that and run the query. I'll save that query for now. So here are all the cast iron assets in the system. Obviously, I can jump to the summary and I can see that there are quite a lot of those assets with quite a lot of failures. I can also see that my construction date ranges from 1927 to 2000. I will move over to the complex query controller, and now I'll set the criteria that I want PARMS to bring back all assets that were installed before 1950. If I save that and then run it, I then have effectively created a query that achieves what I was looking to achieve. So I'll save the changes to that on exiting. And again, you can see what we're doing is we're building up a series of queries in a tree-like structure that means something to your analysis. Let us finish off by looking at the other tools that can be accessed and used. So the other aspects of the Network Explorer are the histograms and the predictions. So if we run a query for the whole of the network and pull up all of the assets that are in the demo database, we can go over into the summary and we can see that within the PARMS Tick demo, there's about 15,000 assets constituting about 684 kilometers. So it's a small section of a network. So if I click from the query down into histogram, it provides me this new view, and then I can tell it what I want to graph. So perhaps length against material. If I'm interested in bringing this into Excel, I can right click, I can copy the series data to clipboard, and again drop the data into Excel. I can also copy the image to the clipboard, which means I can paste the image into, say, a Word document. I can also compare the query to the whole network simply by pressing this checkbox here. So in this case, because we've selected all of the network, so you can see it's exactly the same plot. But for example, if I was to change the query so that I was restricting to only assets that had failed, how would I do that? Well, I go back into my query and I would select all assets that have failed at least one time, not interested in the period. So now I'll run that. And when I go back into my histograms now, the red is now the whole of the network. The blue are just those assets that have failed. So I can see that in terms of the length of cast iron pipe, quite a lot of the cast iron has failed at least once. Again, I can copy this data to a clipboard and I can drop that data into Excel for my own purposes. The other part of the Network Explorer that's worth noting is the predictions. The predictions show how the pipes are projected to perform into the future. So in this case, you can see that we have the predicted failures. We can look at the predicted failure rate, and there are some other options around repair costs, etc., into the future. Again, this is a chart, so if I right-click, I can copy the series data to the clipboard and use that in an external tool, or I can copy the image. So to conclude, we have the setup panel. The first tool that we've been looking at is the Network Explorer. We build up a series of queries in terms of folders and the queries themselves in an Explorer tree. We save those queries for future use. And when we open up a query, we get the query controller. And when we run the query, we get the data in the display, and we can explore that in a range of ways, using a range of navigations to move through to different views, shortcuts, our histograms, and our predictions.